Let's look at the question number 62. You see it says that S is a set whose each element X belongs to real numbers R, and it is non-negative, that is greater than or equal to 0, and it also satisfies this equation 2 mod x root x minus 3 plus root x into root x minus 6 plus 6 is equal to 0. Now looking at the option, it says then S is an empty set, contains exactly one element, contains exactly two elements, contains exactly four elements. So there is nothing much to interpret. The questions is very direct and ask you to first solve the equation. Then they want you to reject the negative roots of the equation since x is greater or equal to 0. And the third step, you have to count the number of non-negative real roots and compare with the options and choose the best option. So let's begin our solution. So if we see in the equation, I see here root x, then again I see root x, then I again see root x. So what I'm going to make it simplified by substituting root x with t. So let root x be t. Let's begin our step with root x be t. And we know this square root x means the positive square root of x. So t will always be going to be greater or equal to 0. Now rewriting this equation, it would be 2 into mod t minus 3 plus t into t minus 6 plus 6. Now here the thing is that you have a mod part. Mod part means it's going to change definition at its critical point. And if you see, this expression will become 0 at t is equal to 3. So the critical point is going to be 3. Before 3, this expression inside is going to be negative. And for the mod part, for making it positive, we'll be multiplying it with minus sign. So we can say if t is less than 3, then mod t minus 3 can be simplified in a form of minus of t minus 3. And for t greater than 3, the mod t minus 3 would remain unchanged and it would be t minus 3. So two cases emerge. So let's first focus on case 1. So in case 1, we have broken that t belongs to 0 to 3. Now as we have seen that mod t minus 3 would be replaced by minus of t minus 3, because before t less than 3 the value is the expression is negative. To make it positive, we have to multiply it with minus. Now again opening up all the brackets and all, we'll be getting the expression like minus 2 into t minus 3 plus t square minus 6t plus 6 is equal to 0. Now rearranging it, we'll be getting the equation as t square minus 80 plus 12. Now factorizing it, we'll be getting t is equal to 6 is equal to 2 is equal to 2 as our solution. As we know that in this case t is less than 3, so therefore we have to reject t is equal to 6 because this solution is definitely greater than 3. So we are not going to accept. So the only solution in this case is going to be t is equal to 2. Now we know the t was not the part of the question. We substituted it. So t would be replaced by root x. So when I say root x is equal to 2, so the solution is going to be x is equal to 4. So x is equal to 4 is one solution. Now focusing on case 2. If you see in case 2, we know t is greater or equal to 3. Now rewriting the equation, it would become 2 into t minus 3 plus t into t minus 6 plus 6. Simplifying it, we'll be getting t square minus 4t is equal to 0. And factorizing it, we'll be getting t is equal to 0 or t is equal to 4 as our solution. As we know t is greater than 3, so t is equal to 0 will be rejected naturally. So the only solution in case 2 is going to be t is equal to 4, which means root x is equal to 4, which means x is equal to 16 is one solution. So final solution can be by combining both the cases. We get x is equal to 4 and x is equal to 6, which means set S contains exactly two elements. Hence option 3 is the correct choice. So we are going to say the answer is going to be then S contains exactly two elements. This is going to be the answer. Just reminding you one important concept here, that when you are solving two equations or inequations simultaneously, you will be getting two type of situation and how you are going to handle it. Let's say if the question says that you have to solve one equation, x belongs to d1 and e1x is greater than 0. At the same time, you have to solve x belongs to d2 and e2x is greater than 0, and both are in cases form, means both has to be solved simultaneously and both the solution would be accepted. So in that form, we are going to solve first equation case 1. Let's say the solution is r1 and for case 2 let the solution is R2. When the solution for case 1 comes out to be R1, and we know the domain in which we are operating is D1, so the first part is going to be R1 intersecting D1. That is going to be the solution of case 1. And for case 2 the answer is going to be R2 intersecting D2, and since these are in cases, the final answer is going to be R1 intersecting D1 union R2 intersecting D2. In the second situation, you will be asked to solve even x is greater than 0 for x belongs to D1 with AND condition, which means you have to select the common solution for both. So even x greater than 0, x belongs to D1, and the second question says E2 x greater than 0, x belongs to D2. While solving this even x, let's say the answer is R1, so this for this part the answer is going to be R1 intersecting D1, and for the second part, for the second stage, x belongs to D2 and E2x is greater than 0, and let's say solution is R2. For this answer is going to be R2 intersecting D2. And since we have to find the solution which satisfies both the inequations, so we are going to take the intersection part. So the final solution is going to be R1 intersecting D1 intersecting R2 intersecting D2. And the same algorithm can be applied for equations.